So here are the first prototypes. We've got color changing with these buttons. I can cycle in both directions. I can put the transmitter in automatic 1-second cycling mode. In this case, the transmitter, which is the Panstamp here, will automatically send a color advanced signal over the radio every 1 second, and then I can stop it by toggling it. Long press on the middle button lets me turn off. Long press on the middle button again will then turn it back on, and then I can cycle it. For reference, I've got a Kingblade X10 in the back here. This is in yellow. Right now the RF controlled sticks are also yellow, so you can compare the colors between the two. And then I'll cycle through red, blue-red, those would be magenta, blue, cyan, this is green and blue, and green, yellow, and then back to red. The overall hardware, and I will turn on the light now so you can take a look. I have here, everything here is basically modules which are Arduino plus a CC1101 Texas Instruments wireless modem. And there are two modules that are sold on the market that have this capability. There's the Panstamp here, and then there's the RFBee by Seed Studio. The RFBee is actually somewhat cheaper, $5, which makes about 25% cheaper than the Panstamp. Panstamp does have a kind of a more compact form factor. I have RFBees currently in the handles. Here's an example of the PC board, the PCB that I designed for it, and then the Panstamp here is in my controller. It's currently wired up to the pan stick for controlling it. I can also wirelessly control. I have a 3.3 volt regulator here if I want to run it with a 9 volt battery. But right now, just so that I can keep the transmitter running all the time, I've got it on USB power. This is the antenna. It's a wire stick. The wire stick is actually pretty good. And then this controls and I've got 3 buttons here hooked up to the digital inputs on the Arduino to control it. I've got headers here because in theory one day I will be able to wire up this nice looking color OLED screen here, and then do some more advanced controlling from the master controller. The sticks, and these are the slaves here. This is basically a 3D printed handle which I designed. There are a variety of flaws in this one. I've got my earlier prototype handle. The earlier prototype handle is it's kind of boxier. And the boxier design is kind of awkward to hold, but is actually quite firm. So I can shake it, and it's pretty rigid. I would say that this is almost concert-worthy level of stiffness. But the boxiness was odd, so I added a bunch of fillets into the corner, really big 14 millimeter fillets in the corner, and that affected the stiffness of this coupler here. And so this is a little bit shaky. You need to probably not concert grade. It'll probably fall apart on its own. The basic design of this handle here is, well, this is really just a prototype. The basic design here is there's a coupler, and the coupler looks like this, and the coupler screws into the original Kingblade diffuser, since I cannot 3D print a diffuser. I don't have the correct material for that. And so this screws into the diffuser, and then there's a slot here, 2 slots actually, one on each side that this snaps into. I've got a wire here, which is what the RGB LED is connected to. That connects into the PC board, and then the PC board sits on this platform here, which is held stationary because the platform is built to fit this PCB and it's clamped on both sides with kind of the matching offsets on the top side, and then the 9-volt battery is held here. There's a step down then that steps down the 9-volt battery to about 3.7 volts, which is a good compromise. The LED driver I have will lose somewhere between 0.2 and 0.5 volts, and that'll take us down to around the right voltage necessary to drive the LEDs at its desired constant current. And then the top end here, these grooves will make the battery stationary. Once everything is clamped down, the system is fairly stiff, right? When I hold it and it's clamped down, I shake it. There's nothing moving around on the inside. Of course, the switch is not accessible while the box is closed. So, to turn it off, I do have to open it up. I also have to open it up if I need to change the batteries. The batteries will last about 5 hours with the current design. I did up the PWM frequency on the microcontroller a bit more. That might affect the power time, and I'll make another, do another experiment where I have an ammeter hooked up to measure the drain on the battery. And right now the switch is in here. A couple of improvements that I need. I need to make this switch in an accessible location. I probably need to move it up to the front here and then build a cutout on the top so it's accessible, but so that you won't accidentally trigger it. Probably does need to be one button on the slave itself, so that if the master is not around, you can use the slave on its own. And then, in general, right, there's no clips or anything. In order to hold this thing together, there is a lip and groove, which you may not be able to see here. So the top and the bottom are different. There's a lip and groove here. The lip and groove actually holds pretty well because I've designed them with 0 tolerance, which means the lip and the groove exactly match. And so once I squeeze this thing together and manage to get it to fit together, it does hold itself together, but it's not secure. There's no tabs or anything. Or screws, and so that would need to be redesigned. The slot that this goes into right now with the fillet is too loose, and isn't rigid, so that needs to be fixed. And of course, I will need an entire PCB to control this. Turn these off. Turn them back on again. All right. I'll need a PCB to put these. To deal with this, so that it's not on a breadboard. This is a very simple circuit, though. I mean, I have no components at all other than the switches and the display. Perhaps display comes as a module, so I wouldn't even need any extra resistors, capacitors, diodes, transistors. It would just be a module. Right? Everything here is built out of sub-module assemblies. But it does function, and it is definitely usable for prototype usage.